Hi to everyone. Hope you are doing good. In this video, we are going to discuss Cascade Forum structure. So, in the previous videos, we have discussed uh, two structures such as direct forum 1 and direct forum 2 structure. Okay, so in this video, we are going to discuss Cascade Forum structure. So, before watching this video, watch my previous video, that is direct forum 2 structure, because uh, in the cascade forum structure we use direct forum 2 in order to realize the cascade forum structure. Okay, so without delay we will start our session. Okay, so cascade forum. Okay, um, let us consider let us consider an IIR means what? Infinite impulse response system with system function h of z is equal to h1 of z dot h2 of z up to hk of z. I mean h subscript of k of z. This is the representation of system function, right? So the mathematical representation of cascade forum structure is this one: h of z is equal to h1 of z dot h2 of z and so on up to hk of z. Okay, this is the mathematical representation of cascade forum. Okay, this is the black diagram representation. Okay, so here we call h1 of z as a transfer function, and also we call this one as a system. Okay, so system function h, you know very well the transfer function equation or system function equation: h1 h of z, right? H of z, this is the general equation. H of z is equal to y of z output divided by input x of z. This is the general equation. Okay, so here we are drawing the structure for each transfer function or system, right? h1 of z, h2 of z up to hk of z. So we are going to draw the structure h1 of z. We are going to use direct forum 2. So we are using the direct forum 2 structure, and thereafter we are combining all the structures like this. So we will discuss one problem, then you are going to understand clearly. Okay, so this is the black diagram representation of cascade forum. Okay, so x of n is our input. This is the overall transfer function. Okay, h of z. What is this? This is h of z. This is my input x of n. H of z is a system function. Okay, y of n is my output of the transfer function or h of z. In the h of z, so we have different structures. Okay, I mean different transfer function or different system function, right? h1 of z, h2 of z, h3 of z up to hk of z. We have connected all the system functions as a cascade. So we are placing the transfer function one after the other. Here the output of h1 of z, that is y1 of n, I am going to give as a input to the second transfer function h2 of z. Similarly, the output of h2 of z, that is y2 of n. So it is entering as a input to the h3 of z transfer function. So the process goes like this. Okay, so this is at the end I will get the output of output y of n of at the last transfer function of h subscript k of z. Okay, this is the black diagram representation of cascade form. Okay, then we will discuss the general equation, okay, or general transfer function of cascade form, how to realize the cascade form structure. Okay, let us consider the transfer function h of z. This is a numerator equation, this is a denominator equation. Okay, these are the second degree polynomial equation, you know very well. Okay, here we are going to split this numerator and denominator equation as a two transfer function. So I will take this one as a h1 of z and this numerator and denominator function as a h2 of z, right? You can also ask, ma'am, shall I take this one and this one and as a h1 of z and this one and this one as a h2 of z? Yeah, you can also take. Here the entire the structure and performance of the filter varies if you are taking like this. Okay, so the order of the filter is very very important. Okay, so whether we are taking this one as a h1 of z and this one as h2 of z, or this one and this one as a h1 of z and this one and this one as a h2 of z, so entirely it changes the filter performance. Okay, and other functionalities, so you will see in the next video. Now, so just we will fit it to the concept, that is, so this one as a h1 of z and this functions as a h2 of z. Okay, there is no confusion, just take this one and this one as a h1 of z and this one and this one as a h2 of z, that's all. Okay, so now the next step is we have to apply direct form to concept in order to draw the structure for h1 of z and h2 of z. Okay, see, this is the h1 of z transfer function equation. Okay, this is numerator, this is denominator. Again, this is h2 of z transfer function, this is numerator equation, this is denominator equation. Okay, now I'm going to draw the structure of h1 of z. Okay, so you have to apply this concept, the procedure of direct form to structure. You have to multiply and divide w1 of z in numerator and denominator. Then I am not going to explain in detail these things, just I will use the shortcut to draw the structure, right? See here, this is my original equation of h1 of z. Okay, so in the denominator equation, so the polarity is going to change, plus 2 minus, if there is any minus symbol, it changes as plus. Here we have only plus symbol, plus sign, so it changes minus. Here plus 2 minus. So our first part of the structure is this one. Okay, and second part of the h1 of z structure is this one. Okay, see here, first one is 1, after thereafter minus a subscript k1 z inverse plus minus a k2 z to the power of minus 2. See here, this is the denominator equation, this is the numerator equation of h1 of z, right? So here in the denominator equation, the first one is, see here, so just see this equation, right? We have x1 of n, right? So this is our x1 of n. It's the first input of the first adder. The second input is minus a subscript k1 w subscript 1 of n minus 1. So how we are using, how we are writing this one? This is a, you know very well, right? W1 of n, right? Z inverse, right? This one W1 of n z to the power of minus 2. While writing equation, we shouldn't use z to the power of minus 2, right? So I have taught all those things in the previous video. Just check it there. Okay. So W1 of n minus 1. The output of this branch is what? W1 of n minus 1, right? So that one is multiplied with, that term is multiplied with minus a subscript of k1. I got this term, right? So again I am going to add with this, right? So my second term is w1 of n minus 2. So if I am writing here another z inverse, the output is of this branch. The output of this branch is z to the power of minus 2, right? And w1 of n, right? So after I am multiplying with this coefficient, so I will get the second term, okay? Second term. So I have to add with this adder element. This is a delay element, this is a adder element. This is a constant, we will say this one as a constant factor. Okay, these things are very important. Okay, so I have completed writing the denominator equation. I have to write the structure for numerator equation. Right, what is that equation? This is the equation. So I have, this is my output, final output. So I have to multiply this w1 of n with the coefficient bk naught. Then after bk1, w1 of n z to the power of minus 1, bk2, w1 of n z to the power of minus 2. See here, this is, I am directly multiplying the bk naught with the w1 of n. So this is the my first term. The second term is w1 of the this, what is this output? W1 of n minus 1, right? W1 of n minus 1, right? Then I have to multiply it with this coefficient. Here the signs should not change. Okay, it remains the same. Only denominator equation sign only changes, right? Except that constant value 1. But numerator equation equation signs does not change. Equation sign does not change. Okay. So w1 of n minus 1 b subscript k1, right? This is added with the w1 of n bk naught. Similarly, bk2 is the coefficient of w1 of n minus 2. This term is added with these two terms. Finally, I will get this equation. That's all, right? This is the direct form to structure of h1 of z. Similarly, you have to draw the structure of h2 of z, right? So after that, you have to combine h1 of z and h2 of z. This is a h1 of z structure. This is my h1 of z structure. This is my h2 of z structure. So here we have applied direct form 2. Okay, direct form 2 procedures to draw the structure of individual transfer function. Thereafter, we have to combine, that is, the output of y1 of n we are going to give as a input of x2 of n. Just we have to combine these two structure. That's all. This is the cascade for a structure of realization. Okay, we will see one problem. This is very simple. Just to solve the quadratic equation. Okay, you have to find out the roots of the equation using calculator. Please keep one calculator along with you during DTSP class, and also very important during exam. Without calculator you can't pass in the DTSP exam. Calculator is must. Okay, don't waste your time to solve the equation in manually. Use calculator and solve the equation. I have already discussed how to solve the equations. Okay, quadratic equation, maybe and two equation or single equation using calculator. Okay, please use calculator to solve the equation. See here, so realize that this is the problem. So might be they will ask for 6 marks or 8 marks. Okay, realize the system with difference equation. So while seeing this equation itself, you come to know this is a discrete time system, right? So if it is continuous means this equation should be in the differential equation. Okay, this is the difference equation, then this is the discrete time system. So in order to convert time domain discrete time signal to a discrete time equation to frequency domain, you have to use Z transform. You know very well, you have studied in your signal and system, right? Z transform. Okay, so here there is no need to solve the Z transform and all. Just the concept of Z transformation, right? If it is y of n minus 2 means how will you write y of z z to the power of minus 2 with the coefficient 1 by 8, right? Minus 1 by 8. How will you write this one? 3 by 4 y of n z y of z z to the power of minus 1. This is x of z plus 1 by 3 x of z z to the power of minus 1, and so on. Okay, or z inverse. Now, after converting discrete time to z domain, okay, you have to separate output equation and input equation. Here output equation is y of z, input equation is x of z. You have to separate that equation in the right hand side and left hand side. In RHS side we have output equation, in the LHS side left hand side we have input equation. So thereafter we have to remove this common term y of z at the outside. So you have to write y of z outside the common, outside the equation. This is the equation, polynomial equation, a second degree polynomial equation, right? So this is, here we have to remove x of z is a common term outside. Thereafter you have to write the transfer function h of z is equal to y of z divided by x of z. You have to arrange the equation like this. If you are multiplying means, so y of z should be multiplied with this equation and x of z is multiplied with this equation, you will get again above equation. Thereafter the important thing is you have to find out the root of this equation in your calculator. So you have to enter 1, right? So you know very well how to do that. Just I am overall I am going to explain. You have to enter the a value as a 1, b value as a minus 3 by 4, c value as a 1 by 8. Then if you will get 0.5 and 0.25. Here usually we will used to write for example z minus 0.5 like this. But here we have z inverse. Keep it in your mind. So you have to write 1 minus 0.5 z inverse. The second term is 0.25. You will get 0.25 output as a result. So you have to write that one as a 1 minus 0.25 z inverse. Keep it in mind while writing this. Okay, here we are using the z inverse term, not z. Okay, you shouldn't write like this, z minus 0.5. This one, this z will goes like this, 0.5. It will comes here. 1 by z means what? Z inverse, right? 1 by z means what? Z inverse. So we have to write like this. After writing this, take this one as a h1 of z, and here consider, here there is a 1, so it is a h2 of z, right? So apply direct form 2 procedure to draw the structure of individual transfer function h1 of z and h2 of z. Later combine these two structure using a single line. That's all. See here minus symbol I have to use plus. This is my x1 of n. This one is 1. x1 of n. This is my z inverse half z, plus symbol I have to change this sign. Okay, minus to plus half z inverse. I got, this is my second numerator equation. This is my w1 of n. This is my 1 by 3 w1 of, see here the direction is very important. So for this one it goes like this, for here it comes here opposite. 1 by 3 w1 of n minus 1. This is my h1 of z structure. This is my h2 of z structure. See here, why this is one is a my x2 of n. This is my x2 of n. This is my, I have to change this sign as a plus. So plus 1 by 4 w1 of n minus 1, that is z inverse. So here I have only 1, so this is my output. Here there is a value 1. So y2 of n is 1. So is equal to y of n. This is my input, this is my output, this is my system transfer function h of z. H of z in what? h1 of z and h2 of z. h1 of z dot h2 of z. This is very simple, right? Don't make confuse, right? Draw, just don't watch this video. So simultaneously solve the problem. Okay, if you have any doubt, put it in the comment box. Okay, if you like this video, kindly subscribe my channel, share this channel with your friends, and like this video. I hope you will understand this concept. Thank you very much. We will see in the next video with new topic, that is parallel structure, how to draw the parallel structure. Okay, thank you. Bye bye.